Is produced by 5 Star Productions USA, which is solely responsible for its editorial content, and is sponsored in part by a grant from Paul Mitchell Salon Hair Care.
People all over the country are getting involved in learning new ways to recycle. It can also be profitable. A middle school in Virginia collected 125,000 aluminum cans in just 2 days and raised $2,000 for its science department. I'm Ed Begley Jr. Join me as today's environment explores everyday alternatives to our tough environmental issues.
Today, City Council is with 9,000
reducing air pollutants by
a milestone.
30%. Educational programs.
With over 80% of the garbage generated in the U.S. going to landfills, which are closing at the rate of 2 per day, our waste problem isn't going away. Here is one waste issue that is being tackled head-on.
Of all the options available to reduce the pollution of the environment, source reduction is one of the most effective. Recognizing this, the EPA established the Voluntary Industrial Toxics Project, which calls for companies to cut in half their use of 17 specified substances by the year 1995. One of the companies committed to this project is Grumman Corporation, a designer and builder of sleek, swift, powerful, agile, and capable aircraft for the armed services. Its efforts to protect the environment are impressive. The company uses 9 of the substances on the Environmental Protection Agency's voluntary list and has pledged not only to meet the goal of 50% reduction, but has forecast as much as a 64% reduction by 1995. Beyond its commitment to the EPA, they will also eliminate the use of Freon, a chlorofluorocarbon used in many aircraft manufacturing processes. Freon contributes toward the depletion of the ozone layer. An 85% reduction will be achieved in overall usage by 1996. Besides enhancing its physical appearance, the paint on a plane must give it the flexibility to travel, from the corrosive decks of an aircraft carrier to the frigid temperatures of high altitudes, often at supersonic speed. To ensure that the paints it uses can meet stringent customer requirements without releasing pollutants into the atmosphere, a multi-million-dollar investment in research has been made to identify new paints that reduce or eliminate those emissions during application. In 1993, a new system that uses waterborne primers and high solids resin technology to reduce solvent emissions will be unveiled. Another way of reducing paint solvent emissions is by expanding the use of airless spray guns, which control the amount of overspray released into the air and have doubled the efficiency of paint transfer. Perchloroethylene, a chemical used to apply a maskant onto metal prior to the etching of patterns in a process known as chemical milling, currently has no suitable substitute. To cut down on the amount of air toxics emitted during this process, equipment designed to capture, condense, and recycle this substance has been installed, which could reduce the amount released into the atmosphere by as much as 98%. To reduce the amount of trichloroethylene released into the air when flushing oil and manufacturing soils from aircraft parts, replacing vapor-decreasing tanks with tanks that use hot water with alkaline-based cleaning solutions will ultimately eliminate all these emissions. By far, the most critical concern in aircraft construction is safety. To prevent corrosion and provide for long-term safety, the use of chromium, which is on the EPA's toxic substances list, is essential. An industry team is investigating alternatives to chrome and is working aggressively to replace chromic baths with new anti-corrosive agents. After years of research, the hope is to replace methylene chloride, another listed substance which is used to strip paint, with 2 new technologies. The first is an environmentally safe chemical stripper, and the second is a mechanical depainting process called plastic media blasting. This process has been proven capable of effectively stripping paint from an aircraft without harming the fuselage. Today, a comprehensive solid waste management program that includes source reduction, reuse, and recycling is an integral part of the Grumman culture. The company currently recycles 31% of its waste stream at its New York headquarters and has aggressive programs at its facilities nationwide. This is a company that has successfully applied the qualities that have brought it to a leadership position in the aircraft industry to the improvement of the environment and promoted the health and safety of its employees and the public.
Chlorofluorocarbons, or CFCs, are the principal material responsible for the destruction of the ozone layer. CFCs are found in coolants, cleaning solvents, and foam insulation. Today's environment looked at one way CFCs are being eliminated.
The integrated circuit has been called the most important invention of the second half of this century, irrevocably changing the world. Microprocessors, or computer chips as most of us know them, the brains of personal computers, have changed the way we see the world, how we think, how we work, and how we play. But as is often the case, their enormous benefits have come to us with a price. After the chips are soldered to computer boards, solvents containing CFCs, or chlorofluorocarbons, are used to clean away the flux residue. With growing concern about the effect of CFCs on the Earth's ozone layer and the threat this poses to the environment, positive action has been taken to reduce and even eliminate the use of CFCs in this process. Very likely, the most dramatic reductions in the use of CFCs in the manufacture of semiconductors has been made by Intel Corporation, the world's leading supplier of microprocessors and the inventor of the computer chip. The existence of significant scientific evidence to support the adverse impact of CFCs on the stratospheric ozone layer motivated Intel to undertake an aggressive worldwide program to immediately reduce and eventually eliminate CFCs and other ozone-depleting emissions. They set the end of 1992 as a goal to eliminate dependence on these substances and are on target to meet that deadline. The two key changes to eliminate CFCs from its manufacturing operations have been to convert from chemically soluble solder paste to attach the chips to the surface of the computer boards to a paste whose residue can be washed away with water, and to use a flux that does not need cleaning for any soldering touch-ups required in the final assembly. Intel has also moved aggressively to reduce its chemical usage, initiating major programs in the areas of waste minimization and pollution prevention. The goals were to significantly reduce the amount of off-site shipments of hazardous waste for recycling, treatment, or disposal. The strategy was simple. They modified existing manufacturing processes or developed new ones to generate less waste. If you don't create hazardous waste, then you don't have to worry about how you treat or dispose of it. It is not only essential to actively pursue this type of strategy for the protection of the environment, but it is also in their best interest. The strategy represents a departure from traditional efforts to protect the environment, which have centered on controlling pollution after the fact. By preventing pollution from being generated in the first place, it doesn't have to be cleaned up. In redesigning manufacturing processes to reduce pollution, microchips are at the heart of providing the precision necessary to control pollution. Intel's efforts in this area have brought about more than a 90% reduction in the amount of hazardous waste produced at its locations from 5,000 tons in 1985 to just 760 tons in 1990, a period in which the company experienced a 32% annual growth rate. This very successful environmental protection program is a model for others in the industry to follow. Saving energy, and with it the conservation of our natural resources, has been a goal of industries and the general public. America's largest wire maker, Southwire Company, has taken steps to address this issue. Their energy reduction efforts began shortly after the energy crunch of the 1970s. They decided to look for ways to reduce energy consumption throughout the organization while at the same time keeping production levels steady. Over a 9-year period, the company has been able to reduce its energy usage per pound of product by 50%. As an example, at its aluminum rod and cable mill in Hawesville, Kentucky, technological innovations have been introduced to decrease energy consumption by 56% since 1981. This has been accomplished largely through two major installations at the facility. The first, which achieved a 40% reduction in energy consumption levels between 1981 and 1985, involved the installation of high-velocity burners on the plant's two furnaces and the application of programmable dual set-point temperature controls. The angling and high-velocity flame increases the fuel efficiency in the furnaces. It directs large quantities of high-velocity flames and gases onto the cold metal charge, which acts like a torch, penetrating the metal. The downward angling also partially eliminates heat losses by reducing the radiant heat transfer to the furnace roof and sidewall refractory during the melt portion of the furnace cycle. Before the programmable controls were installed in 1983, there was a point during the melt cycle where for a period of 45 minutes, practically all heat input was exhausted out with the flue gases. This resulted in the waste of a considerable amount of fuel. To control the situation, tandem controllers were installed on the furnaces, which sense both stacked gas and metal bath temperatures. They enable the operator to reduce the total burner input according to the type of alloy being run, and limit the stacked gas temperature by cutting back on the burner input, which results in substantial fuel savings. By 1984, energy efficiency in the plant's furnaces had been greatly improved. At that point, Southwire had only waste heat recovery remaining to obtain further reductions in fuel usage. This was accomplished through the installation in 1985 of a ceramic tube recuperator, which is suspended in the stacked gas stream. It is designed to preheat 100% of the combustion air for the furnaces. For the 2-year period that the recuperator had been operational, the efficiency improvement was 40.8%. With the success of the first recuperator, another was added to the second furnace, resulting in further energy savings for the facility. This savings in energy made a significant contribution to Southwire's overall company-wide achievement of a 50% reduction in energy usage. It is an achievement that has helped to conserve our natural resources, and by reducing the quantity of emissions, protect our environment. Every day, each person in the United States generates 3.5 pounds of garbage. That adds up to 150 million tons of trash nationwide that must be disposed of each year. At this rate, it has been estimated that 1/3 of the nation's landfills will reach capacity and be forced to close within a few years. Where will the discards of the general public and industry go? One practical solution to the problem that has already been put to the test and has come through with flying colors involves the use of Tensar structural geogrids to improve the environmental reliability and security of landfills while increasing their capacity. These chemically inert durable polymeric grids manufactured by Tensar Environmental Systems have been used in hundreds of applications around the world. Several thousand Tensar installations are now in service. In 1987, Islip Long Island's only operating disposal facility neared its maximum capacity, and its closing was becoming imminent. The town was forced to load its garbage on the infamous barge that traveled up and down the East Coast looking for a home. Its odyssey was covered by all the major networks. To solve the town's problem, Tensar made possible the first use of a revolutionary new piggyback technology, actually building a new landfill right on top of the existing one, which had already been capped or closed off. Like a giant snowshoe, the grids distribute the weight evenly, resisting the stress and limiting the strain, which protects the integrity of both the capping system and the containment lining system. By allowing Islip to expand its landfill, the infamous barge could finally return home. But Islip was only one aspect of how the new geosynthetic technology can increase the capacity of landfills while raising the level of environmental protection. Geogrids offer the opportunity to create the landfill of the future, better able to accommodate our tons of garbage while protecting our groundwater from pollution. Old landfill designs had extremely shallow slopes, limited by the materials that could safely be used while providing a good level of environmental safety. The first step in the new generation of landfill design is making the angle of the interior slopes greater by reinforcing them. This increases the capacity of the landfill, extending its life. Geogrids can also be added beneath the landfill to protect the lining system in case the ground settles. To protect the system from failure or slippage as the landfill accepts the waste, the lining system on the interior is protected by soil veneers, again held in place by grids. Now for vertical expansion. Instead of an old-style shallow exterior slopes, the landfill can be taken higher, holding the soil cover in place with grids. The most sophisticated application of geosynthetics allows the building of additional berms or walls on the outside of the landfill so it can be raised even higher. The final liner is protected from settling by grids beneath it, and the exterior soil coating is held in place by grids above it. As a final step, Tensar erosion matting is added to the outside of the landfill so that it can be seeded and converted to a grassed area.
The technology of the landfill of the future, utilizing Tensar structural geogrids, results in a more environmentally secure landfill, and yet one that has higher capacity. What this means is that fewer new landfills will be needed, and the older ones that we already have can last longer. We at Tensar are proud of our role in helping communities cope with an almost universal problem of too much trash and too little place to put it.
Another of nature's precious resources is oil. In the United States alone, we throw away enough oil every year to fill 120 supertankers. Many cities have instituted collection programs for oil recycling, but there is more in your car than oil that can be recycled. Watch this.
We tend to take for granted some of the pleasures that life brings us. We've grown accustomed to enjoying outdoor activities, surrounded by fresh air and the warming sun. But there have been disturbing indications that this way of life, indeed life itself, may be threatened. Scientists have known for some time that the Earth's stratospheric ozone layer, which is our shield against the sun's hazardous ultraviolet rays, is being eaten away by man-made chemicals. The resulting hole in the ozone layer is a cause for some concern. Chlorofluorocarbon, or CFC, which is used in refrigerant and air conditioning systems, is considered an important factor in the depletion of the ozone layer. Although nations worldwide have joined together to control and restrict the use of CFCs and phase them out entirely by the year 2000, there has been recent alarming evidence that the ozone layer is being depleted even more rapidly than scientists had predicted. One company that has responded to the need to reduce the amount of CFCs and other pollutants escaping into the atmosphere is Win Oil Company. Founded in 1939, the company is a worldwide leader in automotive maintenance, with a special concern for products and services affecting the environment. One example is its Extend Mark X Power Flush coolant recycling process, which allows automobile cooling systems to be flushed while minimizing hazardous waste by recycling the antifreeze. The process is an example of how an engine coolant program can provide a practical and economic alternative to antifreeze disposal while reducing and helping to eliminate discharge of hazardous materials into our environment. The company also manufactures emission control products that significantly reduce exhaust emissions, hydrocarbons, carbon monoxide, and smoke, and result in cleaner air. Added to either gas or diesel fuel, road tests have indicated the product is especially effective in reducing black diesel smoke and particulate emissions which result from engines not burning fuel efficiently. In the specific area of VOCs, volatile organic carbon, they produce non-aerosol shop products that utilize compressed air and a special adapter to eliminate the need for propellants that contribute to air pollution, and a refrigerant recovery recycling machine that enables automotive air conditioning systems to be recharged without allowing CFCs contained in the Freon to be expelled into the atmosphere. The Freon is recovered and recycled back into the system, and the CFCs cannot escape to attack the ozone layer. While there has been a 40% drop in CFC consumption since 1986, thanks in part to companies like Win Oil, it is essential that we all do our part to help protect the environment and with it, our lifestyle.
A national fast food chain recently removed 1 inch from their drinking straws, and they now save over 1 million pounds of plastic each year. Today's environment found people can do a lot when it comes to saving plastic.
The number of communities in the United States facing solid waste disposal problems is reaching new heights. Mandatory recycling laws and landfills that have reached full capacity and have closed have worsened the situation. The plastics component of the solid waste stream has been the subject of increased focus, since it accounts for 20% of the volume of waste disposed of in landfills. Of the approximately 5 billion pounds of rigid plastic containers used for consumer products, high-density polyethylene, or HDPE, accounts for a little over half. It is used to make containers for laundry and dish detergents, shampoo and household cleaners, and food and toiletry items. The second most widely used plastic resin is polyethylene terephthalate, known as PET, which accounts for close to 25% of all rigid plastics used for containers. These can be found primarily in soft drink containers, clear or tinted green, as well as certain other food containers. One company that has taken an active role in attempting to correct the situation is Wellman, a firm that operates a major plastics recycling plant in Johnsonville, South Carolina. The company has been producing textile fibers and engineering resins from waste raw materials for more than 25 years. It is the nation's largest recycler of PET soft drink bottles and handles more than 2/3 of all the plastic soda bottles recycled in the United States each year. The journey for many of the bottles recycled begins at a materials recovery facility, or MRF as the company calls them. One of the company's subsidiaries operates a network of MRFs in North America. The facilities make it easier for a community to meet its recycling needs while at the same time removing plastics from the waste stream. At the MRFs, a highly mechanized system is used to sort the plastics delivered from a curbside collection program set up by the community. It separates PET and HDPE plastics, glass, aluminum, paper, cardboard, and ferrous metals, and packages them into bales that are then shipped to recyclers. Let's follow a bale of PET, which weighs in at about 650 pounds, through the recycling process. The bale is part of the more than 100 million pounds of soda bottles, representing some 1 billion bottles that arrive at the plant from all over North America. The first step is to break apart the bales, separating the clear bottles from the green ones, and grind them. The mixture containing the PET, label, any contents remaining in the bottles, the base cup stabilizer at the bottom of the bottle, which is made of HDPE, and any caps or closures, is put through the wash system. What remains is clean PET and HDPE, with all of the impurities removed. The HDPE from the base cups is colored black and made into pellets, which will be used to make more base cups for soda bottles. The PET, which has been reduced to flakes, is heated and forced through a spinneret, which converts it into strands of polyester. After a series of steps in which the strands are stretched, washed, and crimped, they are dried, cut into staple length, which may be anywhere from 1 1/2 to 6 1/2 inches, and baled. Customers who purchase the bales convert the high-quality polyester fibers into such consumer items as carpeting, pillows, comforters, jackets, stuffing for furniture, and geotextile fabrics used in landfills and for adding stability to other types of construction. So, a journey that began as a discarded soda bottle, which might otherwise have ended up in an already overburdened landfill, has instead been recycled and converted into a completely different, valuable product, where it will have another chance to serve the public.
Today, people are willing to recycle more of what they use. Each year, over 200 million trees are saved due to current recycling efforts. Every time we recycle a ton of newspaper, we not only save trees, but we save something else too. 7,000 gallons of water that would be used to process virgin paper. I'm Ed Begley Jr. Join us next week as we continue to search for more environmental solutions on today's environment.
has been a presentation of 5 Star Productions USA. The preceding program was sponsored in part by a grant from Paul Mitchell Salon Hair Care.